All right, so before this, previously we were looking at latent heat and specific latent heat, and we looked at the very important formula, the very important formula, hold on, the very important formula, which is Q equals to ml, which is specifically latent heat lah. But we also looked at how the specific heat capacity and the specific latent heat, how they are different, and what situations we use that particular type of heat. So I hope that you have an understanding about how this works. Remember, if it is the heating curve like the one that you see over here, whenever there is a flat line, it means that that particular heat there is being used to break the bonds, between the molecules, break the molecular bonds lah. So because of that, the heat that is involved here is called the specific latent heat, because it involves a change of phase with no change in temperature. But when the temperature is increasing, we know that the heat is being used to increase the kinetic energy of the molecules. And when you increase the kinetic energy of the molecules, you're increasing the temperature. So we call that heat the specific heat capacity. So when you're aware of what heat is being used, you know then which formula you should be using to calculate the amount of heat energy. The heat is the same lah, it's just the type of heat. The purposes of the heat is different. And because the purpose is different, the way we count the amount of heat is also different. For specific latent heat, no change in temperature, change of phase. For specific heat capacity, no change of phase. The phase is still the same, either solid or liquid or gas, but there is a change in temperature. Because the fundamental thing about heat is that it can only do one thing at one time. It is either increasing the kinetic energy or it is breaking the bonds between the molecules. It cannot do it simultaneously. The faster we get that understanding into our heads, the easier this chapter will become. As long as we think that heat can do both things at once, that's where we will get stuck and we will always get this wrong. All right, let's begin. Number one, latent heat is hidden because where did I stop the other day? I don't remember who I stopped with the other day. Anyway, let's choose a random person lah. Let's have Chen He. Let's start with Chen He. D. All right. Latent heat is because it is used to overcome the attractive forces between the molecules, otherwise known as the molecular bonds. Specific latent heat is measured in Nordiana. C. All right, very good. C, joules per kilogram. This one is definitely out, like got nothing to do. And I don't know why the B and the D answer is the same. But the B and the D answer is specific heat capacity. SHC. So, very good. Number 3, the following is a temperature time graph for the substance Y, which is heated. It's a heating graph. What is happening at QR? Steffi.
C.
All right, very good. C. Substance Y is melting at this melting point. Because it's melting and this is obviously boiling lah. Thank you. Number 4, specific latent heat of fusion is the heat required to travel. Fusion.
A.
Good. Change 1 kg of ice into water at 0 degrees Celsius. Temperature is constant. No change in temperature, ice to water. And definitely because of the word specific, we have to have the word 1 kg. This one, nothing. This one, totally no. This one, 1 kg of ice by 1 kg of water by 1 degree Celsius. Change the temperature is specific heat capacity. Change water into steam is called the specific latent heat. Allahai. Specific latent heat of vaporization. Be very aware of this. Number 5, there is no rise in temperature when the heat is supplied to melt the ice. Which of the following explains this observation? Vivian, what's the answer for number 5, please? C. The heat is used to increase the kinetic energy. No rise in temperature. Are you sure? Increase in kinetic energy means that there is a rise in temperature. So C is definitely not the answer. Okay, can you try again, please, Vivian?
D.
Okay, D, the heat is used to overcome the attractive forces between the molecules. Okay, still need to understand this, that when there's an increase in kinetic energy, molecules move faster. Move faster means they have to move at a certain temperature. The faster you move, the higher the temperature. Sorry, the higher the temperature, the faster you move. Okay, so this is a very important difference between these two. Okay, which you need to get lah. Okay, number 6, drinks can be cooled by adding in several cubes of ice. When the ice is melting, beyond, sorry.
A.
A, all right, large amount of heat is absorbed, okay, and lowers the temperature of the drink. Because ice is melting, okay, when ice melts, what it does is, it, the heat goes into the ice. But the heat comes from where? The heat comes from the water. And this brings me to a very important thing that we need to understand, okay, which is the thing that flows is heat. Only heat can flow. There is no such thing as cold air can flow. Okay, no such thing. It is either there is heat, there is no heat. If there is heat, it becomes hotter. If there is no heat, it becomes colder. So the question you must ask yourself is, why is this water cold? If the water is cold, it's because there's no heat. So the next question is, where did the heat go? The heat went into the ice. Okay, the ice absorbed all the heat so that the water can become cold. Such an important thing, because from very young we have been taught the wrong thing. Okay, we think that when we put the ice into the water, okay, the ice is the one that makes the water cold. Actually, that is totally and truly false. Okay, what the ice is doing, the ice is actually taking out the heat from the water, and the water, because got no more heat, right, so it becomes cold. Okay, it is not the ice makes the water cold. I mean, okay, fine, we teach that to small kids lah. Okay, like, we teach that to younger children, say, okay, ice makes the water cold. But what is actually happening is that the ice is not doing anything to the water. It's just taking the heat away. Okay, the ice is taking the heat away from the water so that it can melt. Okay, and when it is taking the heat away from the water is left with no heat, so the water becomes cold. Okay, this is such an important thing that we need to understand. So Dion, I'm very glad that you got this correct lah. Okay, very, 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 very important. Okay, number 7, the graph shows a heating curve of a substance. Which of the phases labeled A, B, C, D shows the heat is absorbed during the melting process? Mr. Wong?
B.
All right, very good. D, melting process is solid and liquid phase. Okay, melting process. So there's no increase in temperature. Number 8, Wong is the last one, right? So it's back to Elvin. Elvin, number 8, please. Elvin.
B.
All right, very good. B, it breaks the bonds between the water molecules. Same type of question again and again. Okay, number 9, Bernardine. Specific latent heat.
A.
Okay, A, V, W, and XY. Specific latent heat, oh. Are you sure? A is not correct. VW is change in temperature. There's a temperature decrease. Temperature decrease means specific heat capacity. But I want to ask you specific latent heat. Can you try again, Bernardine? What should the answer
B.
be? Okay, the answer is B. No change in temperature. Okay, when the graph is flat like this, okay, this is specific latent heat. Okay, why? What is the heat used for? To break the bonds between, no, this one is to release the heat so that the bonds can form. Okay, to form the bonds between the molecules. Whether it is heating or it is cooling, okay, the situation is the same. If it is slanted, kalau ada gradient, ada kecerunan, okay, means it is specific heat capacity. If it is flat line, okay, then it is specific latent heat, because the heat is being used to do something else. All right, number 10 shows the heating curve. Naphthalene starts to melt at the time of when? Carlson.
C.
All right, very good. Naphthalene starts to melt at C over here. It starts to melt. Okay, the biggest misconception we always have is we think that the moment we provide heat, then it will start to melt. Wrong, very wrong. Okay, when we first provide heat, it must increase the temperature to a certain temperature, then it starts to melt. Okay, so it's like a condition. Dia macam satu syarat. As long as you don't reach this temperature, you cannot melt. Okay, you must reach this temperature first, then only you can melt. And everything on earth works with this principle. You must reach a certain temperature. That's why it's called a melting point. Okay, it is called a melting point. For example, naphthalene at 78 degrees Celsius, then only it starts to melt. Anything before 78, it is fully solid. Okay, it is fully solid, and then only at 78, then only it starts to melt. Okay, whenever we do experiment, we always think that the moment we start to provide heat, it already start to melt already. Wrong, very, very wrong. Very, very, very wrong. When we provide heat, it must increase the temperature until it reach the melting point, then it can start to melt. Just like just like when you play game, you must reach a certain level, or you must reach a certain amount of experience, right? Then you can go to the next level. Done. Melting and boiling, everything is the same. The thing must reach a certain temperature, then it can start to change to become liquid. Okay, it is not some as you are gaining experience, you are also leveling up. No such thing, right? When you play a game, it's not like that, right? You have to gather this much experience. Wow. Then only you can go to the next level, or your level will be up. Okay, heat works along the same principle. Okay, you must reach a certain temperature, then you can level up. Level up lah. Okay, solid become liquid. Okay, that's the way it works. All right, number 11, I accidentally show you the answer, so I'm going to show this. Latent heat of vaporization is absorbed in B, okay, when water changes to steam. Absorb. Okay, absorb means it's to the right. All right, number 12, what occurs during the melting of naphthalene? Chloe,
B.
did you say B or D? Boy or donkey?
Boy.
Boy. Temperature of the naphthalene does not increase. Oh yeah, you are right. B is the answer. Temperature of during the melting of naphthalene. Temperature of naphthalene does not increase. Okay, it is correct. But in this answer, they give D, which is also the correct answer actually. Okay, definitely heat is released is wrong. Okay, because melting is heat is absorbed. Okay, temperature of the naphthalene does not increase because it is changing. It is melting to become liquid. So actually, I would say B is also the correct answer. The bonding force between naphthalene molecules increases is wrong because melting involves heating up. Okay, kinetic energy of the naphthalene molecules remains constant is also the same. Actually, B and D is the same answer. So actually, if you answered B or D, your answers are both correct. Okay, all right, number 13, the latent heat of fusion of water of heat, yada yada. Ethan?
A.
All right, A, 1 kg of ice during melting without changes in temperature. Most important word for latent heat, okay, is the word without change in temperature. It's the single most important word. Okay, as long as you see increase in temperature, this is definitely wrong. This is all specific heat capacity. Okay, all right. Ari, number 14. This is the calculation question. What's your answer?
Boy.
Boy, okay, 1.68 times 10 to the power of 5 joules. Okay, how much heat is needed to supply change of 500 grams? Make sure you change this one, 0.5 kilograms, okay, times 3.36 times 10 to the power of 5. Why is this 0 degrees and 0 degrees for? It is nothing. It's just to tell you that there is no temperature change. So if there's no temperature change, don't go and sebo-sebo with the MC delta theta. Totally irrelevant. Okay, so the amount of heat is this one, 0.5 times 3.36 times 10 to the power of 5, and you will get this answer. All right, good job, everyone. So let's continue. So in this next part, actually, I just want to talk about the experiment. Okay, take a look at your modules. I want to talk about the experiment. We can't do the experiment yet, okay, but I hope that if we ever go back to school, okay, I want to do this experiment to show you how they determine the specific latent heat of fusion of ice and the specific latent heat of vaporization of water. Okay, so this is the setup, okay, and I think the instructions are already given in your module, so I'm going to skip this part. Okay, what I'm going to do is I'm going to give you the answers for this lah. Okay, so when you heat it up, okay, sorry. So when you put the design inside, when you turn on the power supply, okay, you wait until the water flows from the filter at a steady rate, and then only you start the stopwatch. So you don't start the stopwatch immediately when this thing turns on. No, you wait until it is melting at a steady rate. Okay, then only you start the stopwatch. So the question is why? Why do we not turn on after the heater is switched on? Why is it when we turn on the switch, when the ice is when the ice is being heated up, right, we don't start the stopwatch? Because we want to wait. The ice will be weighted. Okay, the ice will be weighted until it melts constantly. Because when it is melting constantly, this is when specific latent heat is involved. Because we want to count the specific latent heat. We're not interested in the specific heat capacity. Okay, so remember that when you first turn on, okay, so in this case when you first turn on the heater, it is going to increase the temperature of the ice. We don't want that. Okay, we only want to consider the time when there is no temperature increase. So how do you know that there is no temperature increase? When the water flows from the filter funnels at a steady rate. When it is melting at a steady rate, okay, then you start the stopwatch. Okay, so that's the first answer. Second, compare the value of the specific heat of fusion of water with the exact value. Exact value is 3.36 times 10 to the power of 5. Okay, but usually we will get number 2 pula, sorry. We will get a higher value. Okay, we will get a higher value from the experiment because the ice is also absorbing heat from the surrounding. It is not just absorbing heat from the heater. Okay, it is also absorbing heat from the surrounding. So we are going to get a much bigger value. Okay, so that's why we have a set 2. Why is there a control set? Because the ice in set 2 melts because it only gets heat from the surroundings. Okay, so the control set is to ensure that the ice melts due to the heat from the heater only. Okay, so in set 2, actually we don't put the heater, we leave the heater out. Okay, so that it only melts on the surroundings, just to see the difference lah. Okay, but the reason why I'm only briefly discussing this experiment is to tell you that when we do experiment, okay, when we do experiments to determine the specific heat of fusion of water, okay, which unfortunately can only be done in the lab. I think you can do this at home, but it's a little bit tough. Okay, you will find that actually the value of the experiment is higher than this one. Okay, the value of the experiment is higher than the actual exact value. This is 10 to the power of 5, sorry, 10 to the power of 5. Okay, the exact value is 3.34. According to this one, what they got was, they got about 3.37. Okay, they got a higher value. Okay, because there is some heat that is being absorbed from the surroundings, not just from the heater itself. Okay, so that is the first situation which involves the ice. The next one is the specific latent heat of vaporization of water. Okay, so it is the same. Okay, we put the heater into the water, and then it will heat up lah. Okay, but what we will find is the same thing. We will find that the value of the experiment will be higher than the actual value, which is 2.26 times 10 to the power of 6. Okay, we will find that we will get a slightly higher value because, again, the water absorbs heat from the surroundings. Okay, so it is not just receiving the heat from the heater itself. Okay, so it is receiving the heat from the surroundings. That is why when we do this experiment, we try to minimize the heat that is absorbed from the surroundings by wrapping the beaker, okay, or wrapping the bekas, okay, with tissue paper. Okay, because we want to try to stop the surroundings from melting the from absorbing the heat lah. We want to try to stop the absorption of heat from the surroundings. Okay, that is why. So this experiment, sorry lah, we're just gonna go through this very quickly. Hopefully, when we get to go back to school, if we ever get to go back to school, the specific heat capacity experiment, the specific latent heat experiment, we must do. Okay, we must do. If not all of you do, it will be a demonstration lah. Okay, we need to do for ourselves to see that, oh, okay, this is what is happening and how to do it. Okay, but today I want to talk about the applications. Okay, applications of specific latent heat in daily life. We saw one application just now. Okay, as I said just now, when we put ice into water, okay, and since young, we were taught that when we put ice into the water becomes cold because the ice makes the water cold. Actually, that is a misconception. What is the ice actually doing? The ice is absorbing the heat. It's taking the heat away from the water. Okay, just like if you have a fever. Okay, yeah, now we are in corona season. So let's say you have a fever. Last time when you were much younger, and I don't know how many of you experienced this now. So when I was much younger, and if I ever have a fever, what my mom will do is she will take water and she will take a cloth. Okay, and then she will put the cloth inside the water. She squeeze out the water, then she'll put the cloth on my head. Okay, and then of course when the cloth it hits your head, the water is very cold okay, the water is cold. Okay, but somehow what that does, it helps the fever to subside. Okay, why is that so? Think about it. When you have a fever, you have a lot of heat inside you. Kamu punya badan adalah sangat panas. So when you put the cloth on your head like this, when you put the cloth on your head, what is the purpose of this cloth? Yang ada air. Okay, the purpose of the cloth is to absorb the heat from your body so that your body temperature will come down. Okay, you think what this cloth is magic? You put here and then wow, terus my body. No, what it is actually doing is because it is water, because there is water inside, the water inside the cloth will absorb the heat from your body so that when your body's heat is lesser, okay, then your temperature will go down. Okay, and that is actually a very good example of heat absorption. What is happening? What is happening? Okay, in order to explain to you about the process of heat flow. Remember, only heat can flow. Cold air got nothing one. There's no such thing as cold air flows. Okay, it's such a mind-blowing fact to understand that actually there's no such thing as cold air. It's true. It's either air with heat or air with no heat. Okay, there's no such thing as cold air. You cannot create cold air. Okay, you can only push heat into it or you can take away heat from it. Okay, think about it. Okay, you cannot create cold air when you can create hot air, but you cannot create cold air. Okay, all right. Let's talk about this. Change of phase in water. We're going to talk about evaporation. So when ice melts, okay, I think you can copy this if you want, but it's the same as this. Okay, when ice melts, the ice molecules absorb the latent heat of fusion, causing ice to change from solid to liquid. When water boils, the water molecules absorb the latent heat of vaporization, causing water to change from liquid to gas. When water vapor condenses, condensation, okay, when water vapor condenses, okay, the water vapor molecules release heat because it is changing from gas to liquid. So it is releasing the heat so that it can change from gas to liquid. The two most important words is this: absorption and release. Okay, so we need to think of this in terms of like this. Ice change to water, absorb. Water change to vapor, absorb. Vapor change to water, gas. Gas change to water, liquid, release. Water change to ice, release. Okay, so we need to know which heat is being absorbed and which heat is being released. Okay, because it is the release and the absorption of heat that causes the difference, that causes the change of phase. Absorption of latent heat during melting and evaporation can be used to give the effect of cooling. Okay, important thing, when we absorb heat, okay, the surrounding will become cool. Let me repeat this. When something is absorbing heat, okay, the things around it will become cool. Okay, latent heat is released during condensation, however, for the purpose of heating. And we are going to look at these applications in a little while. But let me repeat this once again to make this very clear to you. When something is absorbing heat, everything around it becomes cooler. Okay, it's a very logical statement. If this thing is absorbing heat from me, my hand is going to feel cooler. Okay, not because this thing is making my hand cold, but because this thing is absorbing the heat from my hand. Therefore, my hand becomes cold. Okay, and terbalik, if this thing is releasing heat, okay, if this thing is releasing heat, the surroundings will become hotter. Okay, the surroundings will become hotter. This thing will become cooler, correct? This thing will change phase, but the surroundings is the one which is the one that we want to talk about today. Okay, so let's say you have this lah. Okay, sorry, I don't know if you have this lah, but if you have rubbing alcohol, this is called rubbing alcohol. Okay, and according to this is called alcohol for women. Okay, it is used for cleansing and to provide a cooling, soothing effect on the body. Okay, so the question is this: why is it? There we can see, why does it say that it provides a cooling and soothing effect for the body? Okay, so if you follow this now, what happens is, okay, so you put a few, oh, I cannot have the fan here, but okay, fine. If I put a few drops of this alcohol onto my hand lah, okay, so when the drops fall on my hand, okay, I immediately feel a cool sensation. Okay, can you feel a little bit of cool at your hand? Yeah, I can. I can feel the cool at my hand. Sorry, I'm doing this macam shock sendiri saja kan. But if you can try this lah. Okay. Now, so if I wait for a while, and all the alcohol, sorry, I think I put too much alcohol lah. But let's say I wait for a while and I wait for the alcohol to fully evaporate lah. Okay, it's going to evaporate. So I put it with the fan lah. Say if I put it along the fan, okay, after a while you find that the alcohol will be no more on my hand. Okay, and I will feel, and I am feeling now, okay, I'm feeling that my hand is a little bit, the place where the alcohol was is a bit cooler now. Okay, so why is that? Why is it that? Is it because of the alcohol? The alcohol is room temperature. I just took this out from my cupboard. Okay, but why is it that the alcohol, when it is on my hand, it is able to give me a cooling effect? Why does it say on this bottle? Besides the fact that it's for women lah, I didn't realize that when I bought this alcohol it's for women lah. But the most important thing is this lah, it's able to provide a cooling effect for the body. Okay, why? Padahal this alcohol is not even cold, This alcohol is the water that I'm drinking is colder than my alcohol. Okay, but why is it that when I put the alcohol here on my hand, okay, it gives a cooling effect? What is happening? Okay, that's the question that needs to be answered. What is happening? Okay, think about it in terms of the heat. Okay, why is my hand feeling so cold? Okay, so we find that the temperature of the thermometer will drop. Okay, if I put the thermometer into the alcohol, okay, and then I take out the thermometer, okay, I will find that the temperature will drop. Okay, take a look at this.
To investigate, we'll use several little dropper bottles filled with dropping alcohol. And start this activity by simply taking the alcohol and placing 5 drops of it on the back of your hand.
The same activity this time.
What do you notice? Record your results every 10 seconds for the next 60 seconds. Now, after making your observations, let's try it again. 5 more drops. 2, But this time, blow across your hand. All right, so what do you notice? It gets colder.
Okay, so the first thing you notice is that when you blow it, okay, actually even if you don't blow it, you will realize that your hand is colder. I mean, that place where the alcohol was or is, okay, will feel colder. You will definitely feel the effect of the coldness. Okay, next video.
Now we can set up the same experiment here. I have a thermometer, I have a timer, and I also have a fan so I don't have to wave it back and forth. So we can watch it in real time and see what actually happens. All right, we have the fan going. So our next step is we're going to add 10 drops of the rubbing alcohol to the thermometer bulb. And it starts at about 75 degrees. And we'll let the timer run. We can see the temperature steadily dropping. And we'll run this for about 3 minutes. Students typically found the temperature dropped about 12 to 15 degrees.
Okay, so two things we find is that it feels colder and the alcohol makes the surroundings, okay, or the temperature drop. Okay, so when we do that, okay, what happens to the alcohol when the air is blown to it? The alcohol will evaporate. Okay, so now the alcohol that I put on my hand just now is no longer there because it has evaporated. It didn't boil, okay, it evaporated. It changed from liquid to become gas. Okay, think about it. Liquid to become gas, heat is absorbed. And when heat is absorbed, the surrounding, okay, is cooler. So the beaker is colder after the air is blown into the alcohol. When the alcohol evaporates, the molecules absorb specific latent heat of vaporization. Most important point is this. Okay, there is the absorption of the specific latent heat of vaporization to break the to break the bonds between the molecules. So the surrounding loses heat. And that's why evaporation causes cooling to the surrounding. Okay, when I put the alcohol on my hand, okay, the alcohol is going to absorb the heat from my hand so that it can evaporate. Okay, so that it can break the bond between molecules and it can evaporate. So because of that, the place where the alcohol was, right, that place is going to lose heat. And that's why in that particular place, it will feel cooler. Okay, so that order of things, urutan ini adalah sangat penting. Okay, why does it become cooler? Because I'm losing heat. Why am I losing heat? Because the alcohol has to evaporate. And why does it have to evaporate? Because it is absorbing heat so that it can break the bonds and then evaporate. Okay, so that order of explanation is the important thing now. Okay, dia ada biskut tak? Okay, that order is very important. All right. Do you guys need some time to copy this? I think I can spare some time. Okay, let me continue. So let's talk about a few applications, okay, or specific latent heat. So this is the one that I said just now. Okay, drinks can be cooled by adding in several cubes of ice. Why? First point is when ice melts, okay, and then it absorbs a large amount of heat from the drink. Okay, ice has to melt in order for it has to absorb the heat from the drink so that it will melt. So because of that, the drink loses its heat and the temperature is lowered. Okay, so this is a very, I know it's a very long-winded explanation for such a simple thing, but this is the actual scientific explanation for this. Not just put the ice inside and the ice will make the water colder. Okay, that one is the primary school way of explanation. Okay, but in physics we have to be very specific. Okay, what kind of heat is being absorbed? Okay, actually not necessarily, but you know, a large amount of heat, okay, and the heat we're talking about here is the specific latent heat of which one? Okay, it will be of fusion, because it is ice melting to water. So don't just copy this and be satisfied with this lah. Okay, specify the type of heat. Okay, it absorbs a large amount of specific latent heat of fusion from the drink. Okay, so the drink loses heat and then the temperature is lowered. Okay, number 2, freshness of the fish and meat can be maintained by placing them in contact with the ice. Okay, this is very normal. Let's say if you go fishing and you want to keep the fish fresher for longer, you put them in ice. You don't put them in water. Okay, why? Because ice has a larger specific latent heat. Okay, when ice has a larger specific latent heat, it will absorb a large amount of heat from the fish as it melts. The ice is going to melt. No matter what, the ice is going to melt. Okay, but because it is in this one, okay, it will take a longer time to melt lah. But it will absorb the heat from the fish. Okay, it will absorb the heat from the fish, and so because the heat from the fish is being absorbed by the ice, okay, the temperature of the fish decreases. And we all know if the temperature of the fish decreases, the fish can be kept at low temperature for a longer time. Okay, so the more ice you have, the more heat it can absorb from the fish. Okay, so that's how we maintain the freshness of the fish, by placing them in contact with the ice. Okay, same thing with, well, I guess you can say it's the same thing as a freezer as well. Okay, we put the fish and the meat into the freezer because what happens is the heat is going to be absorbed, okay, away from the fish. We will talk about refrigerator in a while. Okay, but the basic principle is this. It is always the heat. Heat is being taken out somewhere. It's either released from this to this or is being absorbed from this to that. Okay, so 2 situations about cooling down. Okay, 2 situations about low temperature. The third situation is how is steam used to cook food. Okay, so now we're talking about heating up. Okay, so heating up means that you want to release heat. You don't want to absorb heat, because absorption of heat makes the surroundings cooler. If you release the heat to the surroundings, then your surroundings will be hotter. And this is the basic principle of how we cook steamed fish. Okay, water has a very large specific latent heat of vaporization. When it condenses on the fish, okay, that's why we close. Nobody steam fish with the cover open one. That's not called steam fish. That's called, I don't know what it's called. But usually when you steam fish, you tutup, you close the cover, so that whatever steam that rises will touch the cover and will condensate. Right? So when steam condenses on the fish, okay, when the vapor rises over here, it touches the cover, condensate. When it condensate, it will release the specific latent heat directly onto the fish. And your ginger and your tomato and your spring onion and whatever else you put on the fish lah. Okay? And because of that, this enables the fish to be cooked faster. And some people say it's healthier lah, yada 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 yada. Okay? So, so we find that whenever we want to explain about steam fish, when I explain about specific latent heat applications, it's important to know whether the heat is being released or being absorbed. Okay, and we always talk about release to the surroundings or absorb from the surroundings. Okay, and then we talk about what is the effect it has on the surroundings. In this case, the surroundings is the fish lah. Okay, it is releasing the heat onto the fish. Okay, because it has to change from steam to water. In the case of this fish before this, it has to absorb the heat from the fish so that the ice can change to water. Okay, so I've given you 3 examples over here, okay, of how to explain the application of this one. What I want you to do for your homework today, okay, is to explain number 4 and number 5 using the same principle. Number 4 is explain why our body feels cool after sweating. Okay, talk about body feels cool means heat absorb or heat release. Okay, think about it. Number 5, why is the burn due to steam more serious than the burn due to hot water only? Okay, I'm not saying that you should do this, but if you put hot water on your hand and if you put steam on your hand, steam is more serious. Okay, steam, the burning of steam is more serious than the burning of just because of hot water. Okay, so please explain this too as your homework for today, and then take a photo, send it into the Telegram channel. Okay, the last thing I want to talk about is our refrigerator. Okay, so we need to talk about the refrigerator. This is the picture that is in your textbook, but let's talk about this. So in the refrigerator, okay, there is a cooling agent lah. There is a cooling agent which is nama pun cooling agent. Okay, it's a cooling agent because it is used to absorb. Yes, it is used to absorb the heat, and the name of the cooling agent is called Freon. Okay, Freon. So Freon is the name of the cooling agent. So a refrigerator uses the cooling effect from evaporation. Okay, how your fridge works, okay, it uses the cooling effect from evaporation. So during circulation of the cooling agent, heat is absorbed from inside the refrigerator to the outside. Okay, and then released outside. So that means whatever heat is inside the refrigerator will be absorbed by the Freon, okay, by the cooling agent, by Freon, and then it will be released outside. Okay, so this is how the step happens. The compressor, okay, the compressor is this one, okay, compresses the cooling agent, okay, so that it can increase in pressure and its temperature. Okay, and the cooling agent flows over here into what we call the condenser. Okay, everything is at the back of your fridge. You can turn the back of the fridge to look at this. Okay, but the condenser, so what happens in this condenser is that the Freon gas is flowing here. Flow. So when the Freon gas is flowing, the cooling agent releases latent heat during condensation. Okay. Yeah, okay, sorry. It releases latent heat during condensation. Okay, then when it comes up here, it comes to the expansion valve. So what happens over here is that over here it is gas, and then it changes to become liquid. Okay, so it releases the heat into the surroundings. Okay, then this one, when it comes over here, the cooling agent, which is now in liquid form, flows through the expansion valve. The valve has a tiny hole which allows the liquid at high pressure to be ejected into the evaporator tube, which is at lower pressure. So the liquid will change to gas. Okay, and then after that, in the freezer, the cooling agent evaporates and absorbs latent heat. So over here, the cooling agent from liquid become to gas again. So over here is gas become liquid, and then they're gonna, it is released inside here as liquid, and then it becomes gas as it evaporates because it is absorbing the heat from inside the refrigerator. On top here usually is the freezer, right? Yeah. Okay, and then after that, it flows out of the evaporator back into the compressor, and then it goes on and on and on and on and on and on. Okay, let me repeat now. So down here, compressor changes, it compresses the gas. Okay, it is already gas when it is flowing here, it is already gas, but over here, nama pun compressor. Okay, it compresses the gas so that it can increase the pressure and its temperature. Okay, then after that, in the condenser, okay, it will release the latent heat to the surroundings. It won't release the heat into the fridge. No, release the heat into the surroundings. That's why at the back of your fridge, there must be a gap. Okay, because if you put your fridge, and the wall like this, okay, then the heat is going to, be very difficult to be expelled. Okay, the heat is going to be very difficult to be released. So heat is released because of condensation. Okay, it changes from gas to become liquid. So change to become liquid comes over here into the expansion valve. Okay, and in liquid form, okay, it will be ejected into the evaporated tube, okay, which is at low pressure. Goes inside here into the freezer, it will become liquid. It will become gas as it evaporates. Okay, And then after that, finally, the gas will flow out back into here, go back into the compressor, and so on and so forth. Okay. All right. So these are all the applications. This one you can find in your textbook now. Okay. This is all actually all in your textbook. Okay. So applications of melting will be cooling drinks and food with ice cubes. If evaporation will be cooling the body on a hot day. Now this is the assignment that I gave you just now. The cooling system in a refrigerator also uses evaporation. Evaporation is changing from liquid to gas. So this is a absorption of heat. Okay, and then cooling system of the air conditioner, even your aircon also, okay, works on the same principle. Okay, that's why you have cold air blowing out, because the air, okay, has already gone through, and then the heat is taken out from the air, so that whatever comes into your room, okay, is just cold air. Okay, boiling, cooling as liquid nitrogen boils. Okay, and then condensation, process of steaming food, and heating your espresso coffee. Okay, so all these are applications of specific latent heat. Okay, so what is going to happen now? So for today, what I want you to do, number one, what I want you to do is, of course, answer number 4 and number 5. Okay, this is your homework for today lah. Okay, for today. But because Friday we don't have class, okay, because Friday is cuti peristiwa bahkan, Friday is our Majlis Anugerah Kecemerlangan, and you're all invited to watch. So there's no class on Friday. Okay, so what I want you to do over the next few days until our class next Monday is, number one, I'm going to send you a couple of videos, and I want you to just watch these videos for extra information. Okay, information about the aircon, information about the fridge. I think it's good to watch that. Okay, and then I want you to answer the rest of the tutorial questions. I want you to try to answer the rest of the tutorial questions. Next Monday is tutorial, so we will do like what we did just now. Okay, I will call people to answer, and then you answer lah. Okay, so please answer page 103 all the way to page 105. Okay, 103 to 105. Try to answer as much as you can. We will definitely discuss the answers on Monday. Okay, but it will definitely be a lot faster if you try to do it on your own first. Okay, and then if you cannot get, and then we'll discuss and see the answer. We will discuss the answer to see how. All right. Okay, is that clear? Everyone can